Hey there, Charger fam. This is Mrs. Boyd. Today, we're going to stroll through the land of algebraic proofs. We may have talked about this before or something like it, but I feel like it bears repeating and gives us a really great basis to keep moving on with proofs. So let's go ahead and get a list of these reasons, and then we'll move into some actual proof practice. The addition property of equality says if A equals B, then A plus C equals B plus C. If A and B are the same, you can add the same number to them and they're still the same. The subtraction property of equality is the opposite, but very similar. If A equals B, then A minus C equals B minus C. You subtract the same thing from two equal numbers and they still remain equal. The multiplication property of equality, also very similar. If A equals B, then A times C equals B times C. Again, if A and B are equal to each other, then you multiply them by the same thing and they continue to be equal. The division property of equality may feel a little familiar. If A is B and C doesn't equal 0. That's the only caveat of this one because we can't have 0 in the denominator. Then A over C equals B over C. You divide two equal numbers by the same thing and they continue to be equal. The reflexive property of equality looks a lot like the reflexive property that we use in a geometric proof, and that means that A equals A. If you have a number, and we can always assume that it's equal to itself. I know it's shocking. The symmetric property of equality says that if we have A equals B, then B equals A. If one equals the first one, then they must equal each other. The transitive property of equality says if A equals B and B equals C, then A equals C. If A and B are the same and B and C are the same, then that means that A and C are the same. Substitution property of equality says if A equals B, then A may be replaced by B in any equation or expression. Okay, and we've done some of that before. If we have A equals a number, then we can plug that number into the equation and substitute it in. Lastly, the distributive property, we have A times B plus C, that equals AB plus AC. You distribute A across the parentheses. All right, let's scoot down to some geometric properties that we'll use in algebraic proofs. The reflexive property in our geometric proof, segment AB equals segment AB. We've used that when two triangles share a side. Same thing goes for angles. A measure of angle 1 is the same as the measure of angle 1. That's if they share an angle. Likewise, we have the symmetric property that tells us if AB is equal to CD, then CD is equal to AB. Order matters, but if one equals the other, then you can flip-flop it around. For angles, this means if the measure of angle 1 is equal to the measure of angle 2, then the measure of angle 2 equals the measure of angle 1. Last but not least, on the front side here, we've got the transitive property, and that says if AB equals CD and CD equals EF. We fix that. It's supposed to be a D. It looks like a P. I'm not real sure what that is. Then we can say then AB equals EF. It's a lot like the transitive property we used above. What this means for angles is if the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, then the measure of angle 1 equals the measure of angle 3. All works the same. Essentially, we're just using angles instead of segments. All right, let's flip your paper over and let's take a minute to actually practice some proofs. So our given is 3 plus 4 times x minus 2 equals 27. So we're going to write that down. 3 plus 4 times x minus 2 equals 27. And the reason is given. Next, we want to get the x alone eventually, so we're going to subtract 3 from each side. I'm going to write my little in-between step up here. So we subtract 3, and that leaves us with 4 times x minus 2 equals 24, and that's the subtraction property of equality. Next, I've got a 4 on the left and 24 on the right. So I'm going to divide both sides by 4. And that leaves me with x minus 2 equals 6. And that's the division property of equality. Last but not least, I'm going to add 2 to each side. And that leaves me with x equals 8. And that's because of the addition property of equality. All right, that makes pretty much some sense. I'm into it so far. Let's see if we can do another. We've got our given. So the measure of angle 3 equals the measure of angle 4. The measure of angle 4 equals the measure of angle 5. And that is given. Next, we want to see what we can do with that. Eventually, we're going to prove that angle 3 is congruent to angle 5. Well, I can see really similarly to what we did in our reasons on the front that I can write the measure of angle 3 equals the measure of angle 5, and that's the transitive property. I'm trying to spell it wrong. Transitive property. And then the last part that we talked about when we did geometric proofs the first time, we can say that angle 3 is congruent to angle 5 because that's the definition of congruent angles. Angles that have the same measure are congruent angles. 2 more. Let's do another algebraic proof here. We're given 2 times x plus 2 equals 0.5x plus 1. If you haven't tried this on your own, try it now. That's given. All right, so first step, well, we've got to get our variables together. So we're going to distribute 2, and we'll end up with 2x plus 4 equals 0.5x plus 1. And we used the distributive property to do that. Next, I want to get those variables together and the constants together. So let's subtract 1 from each side. That'll give us 2x plus 3 equals 0.5x. And that's the subtraction property of equality. Then, let's see, what are we going to do? Let's subtract 2x from each side and get the x's together. That'll give us 3 equals negative 1.5x. And again, that's the subtraction property of equality. Then we want to, I'm going to scoot this up just a bit. We want to divide both sides by negative 1.5. And that will give us negative 2 equals x. That's the division property of equality. Last one is a little bit on the unnecessary side for me. We rearrange so that x is first, and we do that with the symmetric property. It makes the most sense that we do that because we have to prove that x equals negative 2. All right, last one, geometric proof. We're given angle A is congruent to angle B, and angle B is congruent to angle C. The measure of angle A is 3x minus 4. And the measure of angle C is 4x plus 2. With a lot to fit in that little bitty space. All right. So we can say the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, because that's the definition of congruent angles. Angles are congruent, and then their measures are also equivalent. Now we can say the measure of angle A equals the measure of angle C, because that's the transitive property. If they're both equal to the measure of angle B, then they have to be equal to each other. Next, we're going to say 3x minus 4 equals 4x plus 2, and that's using substitution. I was given measure of angle A is 3x minus 4, measure of angle C is 4x plus 2. I just plug those in. Now, we want to solve for x, so let's let this step be subtracting 3x from each side. And I've got negative 4 equals x plus 2, and that's using the subtraction property of equality. Then we can subtract 2 from each side. I get negative 6 equals x, and that's also the subtraction property of equality. And then last but not least, we can say x equals negative 6 because that's the symmetric property. I have to say those two things are equal and put them in the correct order. I hope this makes lots of sense. I hope you're understanding and picking this up as I would like you to. Please reach out if you have any questions or problems, and I'll talk to you soon.